Okay, in order to decide when the function is increasing, decreasing, positive, or negative, you need to make a graph, because if you don't have a graph, it's really going to be very difficult to try to understand this. So first thing you want to do is go up and figure out what your x-intercepts were, and I believe we wrote them down kind of nowhere, so maybe I'll write them down here. The x-intercepts are -2, 0 and -5, 0, which both of you are pretty good at doing. So here's -2, 0, 1, 2, 3, 4, and here's -5, 0. The other piece of information that we have here is the axis of symmetry, which is x equals -7/2. If you divide those things, it's actually -3.5. So that's about right here. It's not a coordinate, it's an equation. So it's basically a line that goes right in the middle of your parabola. So the vertex is somewhere on that line. So we took that x equals -7/2, subbed it in back into the equation. By doing all the work, you ended up with -9/4, which is -2.25. So I'm just gonna go to -2.25, which is about here, and put a dot for a vertex. Now, I always find it easier to label the vertex on the graph so that it helps you when you're doing the intervals. The fourth coordinate that we have is the y-intercept, which is by subbing in the value of x equals 0 into your function. So it doesn't matter which form the function is in, you just sub in x equals 0, and it's at 10. So 1, 2, 3, 4, 5, 6, 7. Of course, it's way up there. So I think what I'm going to do is just erase that dot and scale this by 2. So 2, 4, 6. So that's -10, 2, 4, 6, 8, and this is +10. So I'll have to change my dot here because -2.25 will now be about right here. Okay, if I'm scaling my y-axis by 2's. So that means my y-intercept is right here, and that way I can draw up my parabola just like that. Now, you can get a fifth coordinate because parabolas are symmetrical. So I'm about 3.5 away, and 1, 2, 3, 4, 5 lines up. So 1, 2, 3.5 away is right here, and I'm going to go to right over here. So it's symmetrical. I just missed the coordinate a little bit, but 1, 2, 3.5. Yeah, it's about here, right about here. Okay, so that's a nice, perfectly symmetrical parabola. And now we need to do the functions for when it's increasing. So increasing means when the function is going up from left to right. So if I go from left to right, from this point here and up, it's when it's increasing. Okay, so that's from this x value right here. So if you realize what the x value is, because it's written right over here, it increases for all x values. All these values here, okay, all these values here are to the right of this point where it starts increasing. So all those values are greater, so it increases when x is greater than -7/2. Okay, so again, you always go for the x value because that's where it starts increasing at -7.2. It doesn't do anything. So at this point here, there's nothing happening. But after that point, to the right of that point, the values start increasing. So the parabola starts going up. Now for decreasing, you'll notice here that it goes down from left to right up until -7.2. So all these values here are all values that are less than -7.2. 7/2, sorry. So x is less than -7/2. So remember that these two for increasing is always the x value. Always, always, always. And you read a graph from left to right. So it's decreasing when the values for x are less than 7/2, but increases when the values are greater than x equals -7/2. Now for positive and negative, the function here is positive right over here. Okay, all of these values are positive right up to all of this. So if you start looking at this, all these values here are positive. So I'm just going to go ahead and fill that in. Okay, so all these are values that are positive. So now we're not talking about x anymore. We're going to be talking about the y values. So what y value is that? That y value, when it's right on the axis, is equal to 0. So for all values that are greater than 0, this function is positive. So it's positive for all values of y greater. In this case, at 0, nothing is happening. Okay, at 0, it's not considered positive and it's also not considered negative. Now for the negative part, it's all the parts, I'm just put this in yellow. It's all these parts right here. So it's between two values actually. So it's negative all in here. Okay, I'll put up a couple pluses here just to remember that. So it's negative when the y values, I always say to my students, put the smallest number on the left, put the biggest number on the right. So it's stuck between -9/4 and 0. So when it's greater than and or equal to -9/4, but less than 0. So positive and negative is when you use a y value. So I would just recommend rewatching this, trying to do different examples. It's usually pretty similar. Sometimes the parabola is never positive. So for example, if you have a parabola that's like this, okay, that parabola will never ever be positive because it's always negative. Let me just go look for a quick example here just to... So for this function here, we can talk about increasing again. I'll put that in pink. So it increases for the x values that are right over here. So those are the x values for which x, all these values are bigger than +2. So all values that are greater than 2, because that's the x value. Remember that increasing and decreasing is the x value. Now, if you got greater than over here, then it's very easy to do. You just kind of switch it for this one, but make sure you get the first one right. Because if you look at the values where it's negative, from left to right, you'll see that all these values here are all values that are less than x equals 2. So that's how we know how to put those signs. Increasing and decreasing, just to remind you, once again, is the x values, okay? And then we move into positive and negative. So I'll just put an X there. Positive and negative is always the y's. So it's positive for all these values here. Okay, so it's just values again that are greater than 0. So if you kind of draw that out, it's all values right over here, all greater than 0. Okay, and that's all that is. The negative part is a little bit harder because the negative part is stuck between two values. It's stuck between -3 and 0. So again, put the smallest number on the left, put the bigger number on the right, and then put the arrows pointing to the left. Now the only thing that you have to realize is one of them needs an equal sign. It's actually y is greater than -3 and also equal, because that -3 has to be considered. But the 0, you do not put an equal sign there because at 0, it's neither positive or negative. I'm just going to try to find another example for which it talks about these intervals. Okay, there we go. Okay. So for this parabola, it's a little slightly different because the parabola is open down. So this one increases from left to right when x is less than or equal to -5, because all these values here are less than or equal to the x value, which is -5. Now, if you are able to write that down, that means that you can just do the opposite for decreasing. But if you take a look, it's decreasing here for all the values that are greater than -5, not equals, because at -5, it's not increasing or decreasing. Now for positive and negative, it's positive between two values. So it's positive between 0 and -5. This graph is a little weird. Just kind of ignore the axes here. I'm just gonna kind of erase, well, I can't erase them. So it's negative, or positive, sorry, between -5 and 0. So positive here. Oh, sorry, that's why it's weird. Okay, sorry, I lied. It's positive for between 0 and 16. I forgot my own advice that these are the y values and increasing and decreasing are x values. So again, these values here are between negative 0 and 16. So you put the smaller number on the left, bigger number on the right, and the arrows pointing to the left. Now the only thing is that I have to put an equal sign here just because at 16 it's actually positive, but at 0 it's not considered positive or negative. So for the negative, it's anything that is less than but not equal to 0. So you have to remember that when it's at 0, it's not positive or negative. So hopefully those examples help you out. I know you'll be saying I have to just go for extra help, so we'll go over some more examples at that point.